Hello, this is Mr. Stansbury. I'm going to take you through the notes for random variables. At the end of this, you should be able to say, I can list the possible outcomes of a random variable and identify it as discrete or continuous. Okay, so first thing, a random variable uses numbers to describe the possible outcomes which could result from a random experiment. Okay, a random variable is often represented by a capital letter such as X. Okay. Now, random variables can either be what we call discrete or continuous. A discrete random variable, x, has a set of distinct possible values. So, like, say, like the number of grains of sand in your hand. That's something that you could start counting. 1, 2, 3, 4, 5, 6. It would be a humongous number, but it is considered to be countable. Okay. A continuous random variable, x, can take any value within some interval on a number line, which is not countable. It's something that you measure. So, for example, the weight of the amount of sand in your hand could be, you could measure that to any degree of accuracy. So that's why we consider that to be something that you can't count. It's something that you measure instead. Okay, so really it's countable for discrete, measured is continuous. Okay. For example, the amount of times it takes Amazon to deliver n pair of grass flip-flops, the n pair is countable because it's a number. So they're going to deliver 1, they're going to deliver 2, they're going to deliver 8,742 grass flip-flops, but it's a countable number. It's like when you go 1, 2, 3, 4, 5, 6, that's countable. Okay. Time to deliver could be measured to any degree of accuracy, so we consider that to be continuous. So it could be, it takes them 5 days to deliver them all. It takes them actually 4 days, 12 hours, or it could be, down to the minute, down to the second, down to, whatever. So that's considered to be continuous. Okay. So we'll take a quick look at an example here. A group of people were asked to watch 3 movies: Food Fight, Baby Geniuses, and Rockadoodle. The random variable x is the number of movies that has a character in it that has the same name as one of their relatives. Part A, list the possible outcomes and corresponding values of x. So what they're getting at here is we could say, let's call Food Fight would be the number of people who have a relative, that has the same name, a character has the same name as one of their relatives in Food Fight. And then we also have, we'll do B for Baby Geniuses and R for Rockadoodle. Okay. So we can make ourselves a little chart here. And we were going to do, like, say x here will be the total number here. So let's say no one has the same name as someone in Food Fight, no relatives, none for Baby Geniuses, and none for Rockadoodle. Means there's none there. How about on this one here, none for Food Fight, Baby Geniuses, but 1 for Rockadoodle? There's 1 total. Right, so we can do 0, 1, 0. There's 1 total in here. 1, 0, 0, 1 total. Now there could be some, let's say we have it in both the Baby Geniuses and Rockadoodle. That's 2. Or you could have it in Food Fight and Rockadoodle. That's also 2. Or we can have it in Food Fight and Baby Geniuses, but not in Rockadoodle. That's also 2. Sorry, I should have made mine a little bit longer here. And then the last option is you could have people that have one of the characters has the same name of one of their relatives in all 3 movies. Right? So this is really just like the group of people. So no one in the group had a relative with the same name as Food Fight, so forth and so on. Okay, so these are all the possible outcomes Okay. And then part B says, what values of X correspond to there being two movies with relatives' names? Okay. So there were these three here. So for part I here, it would just be two, right? Because two movies with relatives' names. And then for B part I had to change that to make it look nice. At least one movie with a relative name. So that means that would work for any of these with one, two, or three. Any one of those would work. Okay? Okay, that's all we have for random variables. If you have any questions on this, please feel free to ask. Thanks.